Kia ora, Year 12. This is a request for Hann, and it comes from the chapter in the textbook on differential equations. I've changed the problem a little bit by taking out all of the stepping stone parts. So I'm just giving you straight up a question that if you got it like this would be quite challenging because you have to see all of the steps along the way. Whereas in the textbook, they broke it down and gave you more hints on what to do. But suppose we're asked to solve the following DE, and we're told that x is greater than 1. That's going to make things slightly less hassle. And when x is equal to 1, y is equal to 3. So when it says solve the following DE, what we want to get down to is we're going to end up getting y equals blah, blah, blah. The first step that we've got to do is always to look at how we can separate the variables. We've got a y thing here, we've got x's here, and we've got x's here. And we're going to split up the dy and the dx. So by the time you're watching this video, that should all feel pretty straightforward. On the right-hand side, we're going to have the x stuff, and on the left-hand side, we'll have 1 over y dy is equal to negative x squared plus 1 divided by this thing here, x squared minus 1 dx. So we get to here, and now we need to integrate on both sides. So on the left-hand side, when we integrate, we'll get the natural log of y. And over here, it's not obvious what to do, right? So we don't have one where we've got 2x over x squared minus 1. So it's not going to be a simple log chain rule thing where I've got this pattern. Instead, I've got a quadratic divided by a quadratic. So we can do something with partial fractions to fix that. I don't know why OneNote just shut down, but there we go. It should be coming back. Okay, so we're going to use partial fractions to split this thing here up because we've got a quadratic over a quadratic. So we know we can simplify that. So let's just work off to the side and see what we can do with negative x squared plus 1 over x squared minus 1. We'll start by expanding out the top line, the numerator. And looking at this, we're going to force in a negative 1. So we did this in class, we did this in a test a little while ago. We've got x squared minus 1 in the denominator, so we'll have negative 1 of those. And we're trying to match this top number up. So now we've got negative x squared plus 1, but we want to have minus 1. So we have to take away 2. And that means that I can rewrite it as negative 1 minus 2 over x squared minus 1. If I want to integrate that, it's starting to get a bit better. This thing here is fine, but this is still not fine. So let's go back up to here and write out where we've got to. So we've got to the integral of negative 1 minus 2 over x squared minus 1 dx. The next thing that you should be able to notice is that we can write the x squared minus 1 as the difference of two squares. So now we're going to break that term there down into partial fractions. I'm not going to do it all inside the integral sign. I'm going to split it up here. So 2 over x plus 1, x minus 1, can be rewritten as follows. We've got a over x plus 1 plus b over x minus 1. So 2 is equal to a times x minus 1 plus b times x plus 1. If you are having trouble with this, it's time that you urgently went over chapter 7 of the textbook. Hopefully not many of you are still having trouble with this. Right, so now we've got let x equal 1. That gives me 2 is equal to 0 here, plus 2b, giving us b is equal to 1. Now we'll do it again. We'll let x equal 0. Oh, sorry, let x equal negative 1. That gives us 2 is equal to a times negative 2 plus 0. So 2 is equal to negative 2a. A is equal to negative 1. So we've got our partial fractions ready to go. We can rewrite this thing here, split into these two, and then we can integrate. So just shrink that down a little bit. and I'm going to put that into my integral. Okay, so all of this is going to come back in here now. We've got the natural log of y is equal to the integral of -1 minus, so 2 over x squared minus 1 is equal to -1 over x plus 1 plus 1 over x minus 1 dx. Being careful with my negative signs, I can see now that this is going to be a very easy integral to work through. That's going to be minus 1 over x minus 1 dx. Right, so we are good to start integrating on the right-hand side. We've got the natural log of y is equal to -x plus the natural log of x plus 1 minus the natural log of x minus 1 plus c. But remember at the start we were told that x was greater than 1, so that means that I can drop these absolute value signs. Right, so we've got the natural log of y is equal to -x plus the natural log of x plus 1 minus the natural log of x minus 1 plus c. Now, I've got one more piece of information that we haven't used, which is that when x is equal to 1, y is equal to 3. I can keep working through here, or I can substitute that in now. And it feels like this might be a good place to do that substitution and work out what the value of c is. So the natural log of 3 is going to equal what? No, that's not right. When x, that's the wrong way around. When x is equal to 3, y is equal to 1. I'm just going to check. Yeah, so I wrote that question down wrong. When x is 3, y is equal to 1. Right, sorry guys. Hopefully none of you have gone ahead and done that all on your own with the wrong point. Yep, so x is 3 and y is 1. And the reason we like that is that the natural log of 1 is 0. So here we get log of 1 is equal to -3 plus the natural log of, what have I got here? Well, I'm going to combine these. So I've got 4 over 2 plus c. So 0 is equal to -3 plus the natural log of 2 plus c, giving me c is equal to 3 minus the log of 2. And that means that I'm ready to put all of this in here and then get an expression for y by doing e to both sides. So y is equal to -x plus the natural log of x plus 1 over x minus 1 plus 3 minus log of 2, and that should be the natural log of y. So if we go e to both sides, we're going to get y is equal to e to all of this. And then we're going to split this out into terms going very carefully. So we can break this down as y is equal to e to the -x times e to the natural log of this times e cubed times e to the -ln2. There is so much cool stuff in this question, right? Because this here, the e and the natural log undo each other. They're inverse operations. So here we've got e to the -x times x plus 1 over x minus 1. And here we've got e cubed. We have to watch out here because this is equal to e to the log of 2 to the -1, right? It's nothing to do with this negative is not going to come down, right? So we have to be really careful with these ones. So y is equal to e to the -x plus 3, so I'm combining these back together now, times e to the natural log of 1/2 times x plus 1 over x minus 1. So we get a final answer here. Y is equal to 1/2 x plus 1 over x minus 1 times e to the 3 minus x. So that's my final answer for that question. So lots of things to notice in there. Just go through this question slowly and look at where you're not confident. So the places that you probably want to watch out is with this last little bit with e to the negative powers, just using your log rules to fix those up. Other places to watch out for things, knowing that you can substitute in before you get to the end of the problem is a good thing to go over. Just noticing why I was happy to drop my absolute value sign here. It's because I was given a condition for x, and that meant that this yuckiness goes away. And then the other two things to really be careful of here are obviously the partial fractions work. You have to be really confident and fluent with that, and just knowing how to separate the variables. So there you go, Han. I hope that helps, and I think there'll be quite a few other people in the class who could do with watching this video too.